All right, we're going to look at electron dot notation. The way the book shows it is you start on the right side of the symbol and you put your first two dots and then you distribute one in a counterclockwise manner. So actually we'll do this. So everything in the first column, so notice this 1A, 2A across here represents this 1A, 2A, 3A, 4A, all the way across. So each column of the periodic table represents how many valence electrons there are. This section down here that's labeled B's, these don't count. So if you noticed, 1A has, all of these have one valence electron. All of this column has two valence electrons. We skip the B section. All of these have 3, 4, and so forth. So everything in the 1A is going to have one dot representing the one valence electron. Everything in the second column is going to have two dots, and they're both going to be on the right side of the symbol. If they're in the third column, they're going to have three dots. Your first two on the right, and then you're going to start distributing one at a time around in a clockwise manner. So 3, then you've got 1, 2, 3, 4, then 1, 2, 3, 4, 5, then 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, 7. Well, technically 1, 2, 3, 4, 5, 6, 7, and then the 8s you distribute all around. So let's pick let me flip my paper over. Let's look at sulfur. So if you notice, sulfur is in the 6th column, so we know it has 6 valence electrons. So you're going to write the symbol, and then you're just going to start counting 1, 2, and then distribute one across in a counterclockwise manner. So 1, 2, 3, 4, 5, 6. So in a sulfur element, the symbol, you're going to have a spot here to bond and a spot here to bond. And actually, water is a perfect example of that. So let's look at oxygen. Oxygen, notice, is 6. So it's the same thing. You're going to write the symbol. 1, 2, 3, 4, 5, 6. So when hydrogen, your H2s, you have one hydrogen that comes in here, one hydrogen that comes in here to bond. And that's why water has that bent shape as opposed to being straight out like that. And it's because of the way these valence electrons are distributed, we know that water has a bent shape instead of straight out. So hopefully this makes a little more sense, and we'll do some examples for homework.